so before we get into this video, I want to make a little aside, and that's that this technique is often called ring modulation sidechain, but in reality, the ring modulation is just one part of the function that we use for this technique. Right? Let's check out the function. The ring modulation part is when we multiply the negative absolute value of x by y, but there's more to the function. Cool. And for the demonstration, I'm going to be using two elements. My tonal element is going to be a bass. Right, and then my percussive element is just going to be these drums. Perfect. Okay, enjoy the video. Okay, so you might be familiar with volume sidechaining, right? A traditional way of this is getting something like a compressor, adding it to a tonal element of your song, and then sidechaining a percussive element of your song to the compressor. So let's sidechain the drums to the bass, and let's create a new audio track, send the bass through to this audio track and record it, and lower the threshold so we get cool. Just ignore all of the sound, there's a lot going on, but if we listen to this, yeah, the volume has been ducked every time there is amplitude information coming through from the drums. So if we play them together, this helps the drums punch through the bass a bit better, right? If we just play the drums and the bass together by themselves with no sidechaining, they there we go. There's a lot of distortion, a lot of clipping, because these are both peaking at -0.3, right? And the summed signal is peaking at 5.71. And in addition, the drums can't really shine through very well because there's so much destructive interference and constructive interference too, which creates harmonic distortion. And we're hearing a lot of that. So a solution to this is using sidechaining, where we duck the signal, right? We duck the amplitude relative to the strength of the drum signal. But the problem is we're removing a lot of information from the bass. Okay, so what if we had a way to remove information from the bass so the drum signal can come through and we don't have all of this crazy interference happening, but a minimal amount of information? And that's what ring modulation sidechain sets out to achieve. So if I delete this, I'll show you what that would look like. This is the bass signal that has been sidechained using the function, the ring modulation function. So you can see when the drum plays, the bass has been notched. Do you see that? At the same point along the time axis, when the drum is loud, the bass has been notched. And here the drum is quiet, so the bass hasn't been notched. Here the drum is quiet, the bass has the drums are quiet, the bass hasn't been notched. So we are keeping as much of the bass information as possible while still removing all of the drum information from the bass so that we don't get interference. So let's play the sidechain bass with the drums together. And you'll hear immediately the drums can come through so much more powerfully, the bass doesn't sound overblown, and we're not clipping, which is incredible. We're playing two, really loud signals together and we're not even clipping, right? So this is a really powerful technique for if you want the drums to really push through the mix. And because we're keeping so much of the bass information, we don't get that like pulsing sound that might not be desirable for us. Cool. Okay. So how do we achieve this? That's the question. So let's take a look at the signals here. So basically what we want to do is we want to take away the amplitude of the drums from the bass. Something important to keep in mind, this center line here represents an amplitude of 0. That's when the wave has no energy and when it's quiet. It can't get quieter than 0. When it starts moving in each direction, it's gaining amplitude, it's gaining energy, and it's gaining volume. So let's imagine a hypothetical scale of 1 to -1. Both ends of the scale have volume, and the volume increases as they approach those points, right? So we want to take away the signal from the drums, but we can see the drums is louder than the bass here. So we want to take it away relative to the drums, so we end up at 0. And the other consideration is that we always want the drums to be taken away from the bass, so they always need to be the opposite phase of the bass. Okay, so they need to be it needs to be taken away relative to the bass, and in a way that only produces destructive interference, so opposite phase. Cool. So the first problem we have with our drum signal is that it's bipolar. We're thinking about loudness on a scale of 1 to -1, where 0 is quiet, right? This is not very helpful when we're trying to think about how much amplitude information to take away from the bass. What we really want is a unipolar version of these drums, and that's what we've got here, right? So you can see it's the same drum signal, but now all of the amplitude values are in the negative. So we have effectively, we've created a scale from 0, which is quiet, to -1, hypothetically -1, which is loud, right? And it's important that we have a negative unipolar signal instead of a positive unipolar signal, and you'll see why in just a little bit. Cool. So our next step is to take away this unipolar signal from the bass signal, right? But we can't just take it away for the same two reasons that we discussed before. We want it to be relative, we want it to be scaled to the bass, so that if the drums are louder, the bass ends up at 0. It doesn't go back into the positive or back into the negative. And the other consideration is that we always want the phase to be the opposite of the bass, so that we're always causing destructive interference. So addition is not the operation that we need here. We need multiplication, right? If we multiply these two signals together, we get the outcome we're looking for, right? We're scaling it, and we're always getting the opposite phase, right? And the opposite phase comes from the fact that this is a unipolar signal. Every time we're multiplying a negative number by a negative number, we get a positive number, which is going to be the opposite phase of the bass. Yeah. Every time we multiply a positive number by a negative number, we're going to get a negative number, which is going to be the opposite phase. Okay, so the fact that this is negative means that when we multiply, the product is always going to be at an opposite polarity, opposite phase of the bass signal. And obviously we're timesing it. So let's say this is -1 and -0.1. We're saying the resultant signal is this, like scale to this, right? It's going to be -1 times -0.8. -1 times -0.8 is going to be 0.8. And yeah, so this is the resultant signal of that. As you can see, the drums have been scaled to the bass, and in such a way that the phase is opposite, right? So when this is negative, this is positive. So if we add these two together, we're going to get the destructive interference we need to get our final sidechain signal with the drum information cut out of it. Yeah? So that's the process that we're going through. And yeah, so we can map this as a function where x and y are our inputs, right? X is the drum input, and y is the bass input. I'll move this up here. And these are the operations. So when we're making a unipolar wave from our bipolar wave, that's what's happening here, right? We're taking the negative absolute value of x at any given point along the time axis, and then we're multiplying that by y to get this signal here, right? And then we're adding that back to our original bass signal plus y to get our final output. Cool. So how do we actually do this in Ableton? Let's have a look. Oh, by the way, I came up with this function by myself. I'm not a mathematician, so if you are a mathematician and you see any mistakes, please let me know. I would love to know. Cool. So how do we set this up in Ableton? So let's let's just hide all of these. Okay, so the first step was to get the unipolar signal from our bipolar drum signal, right? And we need a wave shaper for this, and you can get these plugins for free if you just download them. Wave shaper, cool. We want to turn the wet up to 100. We want to turn it to asymmetric and squared. We want to right click, snap to grid, and then if we double click to create a new point, we want to center it. Okay, so this shape is going to negatively rectify the drums, right? Rectify means we're taking an alternating current and turning it into a direct current, right? We're taking the bipolar signal and turning it into a unipolar signal. So we've got that on our drums, and let's record it out and see what happens. Cool. Yeah. So we get the unipolar signal that we're looking for, right? So that's the first step of the process. Now, what comes next? Let's look at our function, right? So this is the unipolar part. That's what the M wave shaper is doing. Now we need to times it we need to multiply it with our original base signal, which is Y. Okay, so how do we multiply? Well, that's where the ring modulation part comes in. So if we get this and we put it onto our bass and we turn the sidechain input on, basically we're saying the bass is the carrier wave and the rectified drums, the negative unipolar drums, become our modulator wave, our modulator signal, and that goes through the sidechain input, right? So let's set the sidechain input to audio 7 audio with our unipolar drums, and let's record that out and see what happens. So, solo this, send this to 8. Perfect, yeah. So now we've got our ring modulated signal. Now remember, the final step in our function was to add that ring modulated signal back to our original bass signal. Right, this is just addition. So how we can do addition in Ableton is just send both of the tracks through to our both of the tracks through to one track. So let's solo this and solo these two and this one here and record that. And to disable the ring modulator might be helpful. Actually, I'll just disable it. Cool. Perfect. Yeah. So you can see here we've got our we've got the final ring sidechain signal that we need. That if we compare it to the drums, it's notching out the information from the drums. From the bass. So when the drum is loud, it's getting notched out of the bass. Okay, perfect. So obviously we don't want to go through this arduous process every time we want to use ring modulation, sidechaining in our Ableton project. So we can create an audio effect rack that we can use every time. We can just save it as a preset and load it up every time we want to do this in our project. So let's do that. We'll create a new audio track, right? Let's get our audio effect rack, and let's check it here. Let's call this Sidechainer. It's going to delete these because we don't need them anymore. Cool. And let's call our audio effect rack RM Sidechainer. Okay, perfect. So in order to understand this, let's work backwards. So the final signal we want coming through our audio effect rack is going to be our this signal here, like this sidechain signal. So how did we get this sidechain signal? Well, we got it by adding our original bass signal with our ring modded signal. So let's create a chain for our original signal, and let's create another chain for our ring mod signal. Cool. And these will add together because they're in a series. Yeah, so these will add together. Cool. So how did we get our ring modulated signal? Well, we got it by by multiplying our unipolar signal with our original signal. Cool. And we use the M-ring modulator for that. So let's take actually we can just steal it from here. Let's check it onto our sidechainer here. So we want it to go into this chain. And make sure sidechain is enabled. Cool. So how did we get this ring mod? We got it by multiplying the sidechain of the unipolar drums with our original signal. So we need to find a way to get our unipolar drums. So let's create a new chain for our unipolar drums. And remember, we got this by getting the M wave shaper from the original drum signal. So let's put the M wave shaper into this chain. Now we need to find a way to route this signal from the drums into the wave shaper. We can do that with an Ableton audio effect that has a sidechain routing. So we can use the compressor, or we can use the gate. I'm going to use the compressor, chuck it here, make sure that your sidechain input is turned into your from your drums. Really important, make sure your EQ is off, right? And then make sure this symbol here is on, and this will route the signal from the sidechain through the compressor into the M wave shaper. If you don't have that enabled, then you're just going to get the bass. You're going to get the Y signal coming through here. And we actually don't want to hear the rectified drums, so let's turn it off, right? Okay, so now we need to send the rectified drums through into the ring modulator. So we need to take the sidechain from inside the sidechainer, and we want to get the unipolar post effects. We can't do post mixer because it's off. If we did post mixer, we won't get a signal. Okay, so let's just think about everything here. We've got our rectified drums, our unipolar drums. Yep, they're being sent to our ring modulator, which has the input as our original bass and the sidechain as our unipolar drums, and then these two are summing. So that should be this entire operation going on with it from within this audio effect rack. The last thing that we need to do is actually send the Y signal through, right? We need to send the bass signal through, and we do that by just sending it to our sidechainer from here. And then we want to make sure our sidechainer is auditioning audio. So if we've done this correctly, when we record our sidechainer, let's create a new audio track and send it. We should be getting, make sure nothing's soloed, we should be getting a signal that looks like this one here. And we are, right? We're getting an identical signal, so we've done it correctly, which is awesome. Okay, I'm going to delete this. I'm going to hide all of this. Make sure your drums are sent to main. Your bass is going through the sidechainer. And if we now just play, make sure this is getting sent to main too. And if we play, cool, and everything is perfect. That is your sidechainer set up. Now you might notice that there is a bit of peaking. So these are at -0.3, right? And this is at basically 0. And we can offset that by turning the strength of the ring mod up by 0.3. Yeah, and that reduces distortion. Now you might notice that the process that we've used does create a little bit of distortion, and we can minimize this by combining the ring modulation sidechain with traditional volume ducking. And what I really like to use is shaper box. So let's chuck a shaper box onto our sidechainer, right? And let's sidechain, so audio, and this is a sidechain button. So the distortion is happening mostly in the kick, right? So let's separate the kick out here. And we can duplicate these out. Let's loop this. And then let's get this, go back to our sidechainer. Let's set the input from the 2 drums. Let's group these, call this drum group. Now let's send the drum group. Let's make sure the drum group is the input of our unipolar M-Wave shaper. Cool. Yeah, perfect. So we're doing a bit of, we're combining a bit of that traditional volume ducking with our RM. And this is reducing the amount of distortion. Now you might want to make this multi-band, right? By removing some of the high frequencies from this volume ducking. But you'll notice there's a problem when we do this. We're getting some peaking. And the reason is because some of the signal is allowed to come through, creating unwanted interference. So the way we fix this is just by putting our shaper box before our ring modulator sidechainer. Perfect, and it's so wonderful. This is such an amazing technique. I love it so much. Yeah, so I hope some of this was helpful for you. And maybe, hopefully, I explained it in a way that hasn't been explained before. And yeah, good luck with this. Let me know how you get on.